For centuries, we've gazed up at the night sky, searching for our place in the vastness of it all. We found comfort in the order we see the graceful arcs of stars, the magnificent spiral arms of galaxies, and the elegant mathematical laws that govern even the smallest particles. It all points to a universe of symmetry, balance, and a hidden, beautiful order. But what if that's only half the picture? What if, just beyond our sight, a cosmic counterpart exists? A universe that mirrors our own in ways both subtle and profound. This is the story of the shadow universe. Imagine a realm existing parallel to ours, a ghostly reflection we cue and see, but whose presence is woven into the very fabric of our reality. Could our universe be just one side of a cosmic coin? A reality where every particle, every force, and maybe even time itself has a hidden twin, a secret counterpart. This idea might sound like science fiction, but it's a concept that physicists are seriously exploring. From the mind-boggling world of particle physics to the grand architecture of galaxies, scientists have always been fascinated by symmetry and the profound questions it raises.
Ow.
Could a mirror world solve some of the biggest puzzles in science? Think about dark matter, that mysterious substance that makes up most of the universe's mass, but remains completely invisible. Could it be matter from this other side, its gravity reaching across the veil to shape our own cosmos? And what about life itself? The molecules that form the basis of life on Earth all share a specific handedness, a strange asymmetry that has baffled scientists for decades. Could this be the result of an interaction with a mirror universe, where life is built from the opposite-handed molecules? The implications are staggering. If a shadow universe exists, it wouldn't just be an abstract concept. It would be a fundamental part of our own existence, silently influencing everything from the way galaxies form to the very chemical building blocks of you and me. Today, we're on the brink of new discoveries that could turn this incredible idea into scientific fact. Experiments deep underground are hunting for elusive particles that might be messengers from this other realm. Telescopes are peering into the cosmic dawn, looking for faint signatures that our universe isn't alone. We're redeveloping theories that stretch the limits of physics and challenge our most basic assumptions about what is real. So, how would we even begin to search for such a universe? What clues are hidden in the data we've already collected? And what would it mean for humanity if we found definitive proof that we are part of a much larger dual reality? The discovery would reshape our understanding of the cosmos and our place within it forever. It would be the ultimate revelation that the universe we know is just one half of a magnificent mirrored whole. Join us on this journey as we explore the foundations of this daring idea. Dive into the scientific discoveries that hint at its existence, and uncover the tantalizing possibilities a shadow universe might hold for our understanding of reality itself. The answers to some of our deepest questions might be hiding in plain sight, reflected in a cosmic mirror we're only just beginning to perceive. Have you ever looked up at the night sky and wondered if we're truly alone? Not just in our universe, but if our entire reality might have a hidden twin. Today we're diving deep into one of the most mind-bending ideas in modern cosmology, the mirror universe. Is it possible that a shadow cosmos exists alongside our own, a perfect reflection of everything we know? Let's find out. To understand the idea of a mirror universe, we must first journey back to the earliest moments of cosmic history. The universe as we know it began approximately 13.8 billion years ago in an event we call the Big Bang. In the first trillionths of a second, the universe was unimaginably hot and dense, a seething plasma of energy and particles. And within this primordial chaos, a remarkable principle emerged. Symmetry. Symmetry, in physics, is the idea that certain transformations leave the laws of nature unchanged. Imagine rotating a perfect snowflake, or flipping a geometric shape in a mirror. Its fundamental structure remains intact. At the level of fundamental particles, symmetry governs the behavior of matter and energy. It's the invisible scaffolding that holds reality together. This concept isn't just a mathematical curiosity. It's a foundational pillar of the standard model of particle physics, describing how everything from quarks to photons interacts. Without symmetry, the universe would be an incomprehensible jumble of random events. It dictates that the laws of physics are consistent everywhere, whether you're here on Earth or in a galaxy billions of light years away. It's this universality that allows us to even contemplate the existence of another universe governed by the same rules. One of the most profound examples of symmetry is the existence of antimatter. For every particle of matter, there exists an antiparticle, a mirror image with the opposite electric charge. An electron has a positron. A proton has an antiproton. When matter meets antimatter, they annihilate each other in a burst of pure energy. Following Einstein's famous equation, E equals mc, in the early high-energy universe, matter and antimatter should have been created in perfectly equal amounts. Yet as we look around us, our universe appears overwhelmingly dominated by matter. Antimatter is incredibly scarce, only produced in high-energy events like particle collisions or radioactive decay. So where did all the antimatter go? This profound mystery, known as baryonic asymmetry, is one of the biggest unanswered questions in physics. This very asymmetry hints at the tantalizing possibility of a hidden counterpart or reflection of the universe where antimatter might dominate. Could this be a shadow realm? A mirror universe where the rules are the same, but the particles are inverted? Imagine a universe where everything is made of antimatter. It would have anti-stars, anti-planets, and perhaps even anti-life. On the inside, it would look and feel completely normal, just like our own. The laws of physics would operate identically. What if our two universes were ever to touch? The result would be catastrophic annihilation. This leads to the fascinating question. If such a universe exists, why is it separate from ours? The answer might lie in the very fabric of space-time itself. Another clue lies in one of the most elusive particles in nature, the neutrino. These nearly massless ghost particles flood the cosmos by the trillions every second, streaming from the sun and distant supernovas. Yet they rarely interact with ordinary matter. A neutrino could pass through a light year of solid lead without hitting a single atom. What makes them even stranger is their handedness. Most fundamental particles come in both left-handed and right-handed versions, like a pair of gloves. But for some reason, we've only ever observed left-handed neutrinos. Where are all the right-handed ones? Some theories suggest that these missing right-handed neutrinos could be oscillating between our universe and a mirror counterpart, passing undetected through the veil that separates worlds. They would be citizens of both universes, acting as a potential bridge or messenger between them, their ghostly nature allowing them to slip through the cracks of reality. The concept of symmetry breaking is key to this whole idea. In the first fractions of a second after the Big Bang, the universe was perfectly symmetrical. All the fundamental forces were unified into a single superforce. But as the universe expanded and cooled, these symmetrical states became unstable and broke, giving rise to the universe's diversity. The distinct forces of gravity, electromagnetism, and the strong and weak nuclear forces. This process is similar to how a perfectly balanced pencil on its tip will inevitably fall in one direction, breaking the rotational symmetry. This breaking of symmetry is why we have stars, planets, and life, rather than a featureless sea of energy. Yet, some theorists propose that this breaking of symmetry could have had a twin outcome, a shadow universe evolving alongside our own. A mirror reflection born from the same cosmic blueprint. Just as the pencil could have fallen in any direction, perhaps the universe split into two realities, each representing a different outcome of that initial break. The foundations of a mirror universe are therefore rooted in the very principles that govern reality. Symmetry, duality, and the subtle imperfections in these symmetries suggest that our universe may not be unique. The laws of physics, consistent and universal, might apply equally to a hidden twin world. This isn't just science fiction. It's a serious hypothesis being explored by physicists trying to solve some of the deepest cosmic puzzles, like the nature of dark matter. What if dark matter isn't a new type of particle in our universe, but rather the gravitational influence of ordinary matter in a parallel mirror universe? We can't see it or touch it, but we can feel its gravity reaching across the dimensions. This would elegantly explain why dark matter seems to exist in a halo around galaxies, mirroring the distribution of visible matter. So, how could we ever prove such a thing? Scientists are designing experiments to look for the subtle signs of a mirror world. These could include precision measurements of neutron decay, or searching for the telltale oscillations of particles vanishing from our reality and reappearing. At places like the Oak Ridge National Laboratory, researchers are firing beams of neutrons at impenetrable walls, hoping to see if a tiny fraction manages to tunnel through. By briefly transforming into their mirror counterparts, passing through the mirror wall, and then transforming back on the other side. A single particle detected where none should be could rewrite our understanding of reality. We might also search for gravitational waves ripples in space-time that could be generated by events in the mirror universe, such as the collision of two mirror neutron stars. These waves would pass from their universe into ours, giving us a ghostly echo of a cataclysm in another reality. A mirror universe could also solve another cosmic riddle, the Hubble constant tension. This is a major discrepancy in measurements of how fast the universe is expanding. Measurements from the early universe, like the cosmic microwave background, give one value, while measurements from the modern universe using supernova give a slightly different, faster value. A mirror universe could potentially resolve this. If a small fraction of our universe's energy is periodically leaking into the mirror world, it would subtly alter the expansion history, potentially bringing these two conflicting measurements into alignment. It's a wild idea, but it fits the data surprisingly well. Imagine for a moment what this other universe would be like. If it's a true mirror, then its arrow of time might even run backward relative to ours. From our perspective, its entropy would be decreasing. Its galaxies would be contracting into a big crunch while ours expand. Could it be populated by beings of antimatter, living out their lives under anti-suns, completely unaware of their matter-based twins? The thought is both humbling and inspiring. It suggests that reality is far grander and more complex than we ever imagined. Our entire cosmos, with its hundreds of billions of galaxies, might be just one half of a greater whole. The search for a mirror universe pushes the boundaries of science and imagination, forces us to question the fundamental nature of reality and our place within it. While the idea remains speculative, it's built upon the solid foundations of symmetry and particle physics, and it offers elegant solutions to some of the biggest problems in cosmology. Whether we ever find definitive proof or not, the quest itself expands our horizons and reminds us that there are still vast, undiscovered territories in the cosmos, perhaps existing just a quantum leap away from our own. If the foundations of a mirror universe are laid in symmetry and symmetry breaking, the tangible clues lie in the particles and phenomena that inhabit our own. These aren't just abstract ideas. They're real, measurable, and sometimes incredibly elusive components of reality that hint at a deeper, unseen reflection of everything we know. Our first stop is the world of particle physics, right at the heart of places like CERN. Here, scientists smash particles together at nearly the speed of light, and what they find is fascinating. One of the most significant clues is antimatter. First predicted by the brilliant Paul Dirac back in 1928, antimatter is the perfect mirror image of ordinary matter. The positron mirrors the electron, the antiproton mirrors the proton, and so on. In theory, the Big Bang should have created equal amounts of both. But when we look around, all we see is matter. So, where did all the antimatter go? This massive imbalance isn't just a quirky detail. It might be the cosmic footprint of a hidden mirror universe. When a particle of matter meets its antimatter counterpart, they annihilate each other in a brilliant flash of pure energy. It's the ultimate disappearing act. Labs like CERN's antiproton decelerator are dedicated to studying the subtle differences between matter and antimatter, trying to solve this very puzzle. Could the missing antimatter have been shunted into a parallel universe, one that's invisible to our instruments? Or does it exist as a separate branch of reality, governed by identical laws but moving alongside us unseen? The answer could fundamentally change our understanding of cosmic history. Next up, let's talk about neutrinos, the ghosts of the particle world. Trillions of these tiny particles are streaming through your body right this second, but you'd never know it. They pass through ordinary matter almost as if it weren't there. One of their strangest behaviors is oscillation. They can switch between different types, or flavors as they travel. This has puzzled physicists for decades. Some theories suggest that neutrinos could be messengers between our universe and a mirror world. Imagine them oscillating back and forth, briefly bridging the gap between two separate realities. If this is true, neutrinos aren't just fundamental particles. They're cosmic couriers, carrying secrets from a universe we can't see. This leads us to an even more mind-bending idea: twin particles. The mirror universe hypothesis proposes that for every single particle in our universe, every electron, proton, and neutron, there's a mirrored twin. These mirror particles would have the same mass, but would interact with their own set of mirror forces. Critically, they wouldn't interact with our photons, the particles of light. And if you can't interact with light, you're completely invisible to us. These twin particles would form mere atoms, mere molecules, and potentially entire mere stars and galaxies, a whole cosmos coexisting right alongside our own, gravitationally entangled but utterly unseen. Think about what that means. A universe that's fundamentally hidden from our view, but not entirely disconnected. Mirror matter wouldn't emit or reflect the light our telescopes are built to detect, making it invisible. But it would still have gravity, and its gravitational pull could solve one of the biggest mysteries in astronomy: dark matter. The invisible mass that holds galaxies together forms the vast cosmic web, and makes up most of the matter in the universe. Might not be some exotic new particle. It could simply be mirror matter, the stars, planets, and gas of a parallel universe, its gravitational presence felt across the void. The idea of mirror symmetry in physics isn't new, but has a rich history. Back in the 1950s, physicists Sung-Dao Lee and Chun-Ing Yang made a shocking discovery. They found that certain subatomic interactions violate something called parity symmetry. In simple terms, it means the laws of physics aren't always the same when reflected in a mirror. This was a huge deal, suggesting nature has a preferred handedness. Later, theorists like Sheldon Glashow took this idea further. He proposed the existence of a mirror sector, a hidden symmetrical realm where parity is restored, and the universe is perfectly balanced in ways we just can't directly observe. Fast forward to today, and physicists are actively hunting for these invisible mirror particles. They've designed incredibly sophisticated experiments to try and catch a glimpse. Deep underground detectors are shielded from cosmic noise, listening for rare, unusual particle interactions. In massive particle accelerators, scientists are looking for subtle signs of energy disappearing from our world, potentially leaking into a mirror one. Each experiment is a painstaking step towards either discovering a shadow cosmos or confirming that we are, in fact, alone. Every collision and every measurement could be the one that finally reveals the truth. The implications of this are truly profound. If twin particles and mirror matter are real, then the universe is infinitely more complex and grand than we ever imagined. Everything we see, every galaxy, star, and planet would be just one half of the complete picture. Hidden alongside this familiar cosmic tapestry would be a shadow universe, silent and invisible, but bound to ours by the fundamental laws of physics and the very fabric of space-time. It would mean that for every event in our universe, a parallel event could be unfolding in another. So far, we've followed the trail of clues, from the mystery of missing antimatter to the ghostly nature of neutrinos, and from the concept of twin particles to the possibility of mirror stars. Each piece of evidence paints a tantalizing picture of a shadow universe that mirrors our own, yet remains just beyond our grasp. But as scientists dig deeper into these ideas, the mysteries only multiply, leading us to even stranger theoretical frontiers and paradoxes that challenge our very understanding of what's real. Stay with us as we venture into the next chapter, where things get even weirder. For decades, we've stared into the darkness between stars, knowing something was missing. The cosmos we see accounts for only a fraction of what must be there. But what if the missing piece isn't just dark matter, but an entire hidden universe, a reflection of our own? This is the story of the shadow universe, a realm glimpsed only through subtle clues and the language of mathematics. As we peer deeper into the fabric of reality, we're forced to ask profound questions. Could there be a universe where time flows backward? Could a mirror matter explain the invisible scaffolding that holds galaxies together? And if such a cosmos exists, what does it reveal about the nature of reality itself? One of the most mind-bending possibilities is a reverse time mirror universe. In our world, the arrow of time is defined by entropy, the relentless march from order to disorder. A shattered glass never reassembles itself. But some theories suggest a mirrored reality could experience time in reverse. Imagine a cosmos where entropy decreases, where shattered glasses fly back together, and where our endings are their beginnings. In such a place, cause and effect would be completely alien to us. Events we see as final might just be the start of something new from the perspective of a mirror cosmos. The scientific basis for this strange idea lies in something called CPT symmetry. It's a fundamental principle stating that if you flip a particle's charge, invert its spatial coordinates like a mirror image, and reverse the flow of time, the laws of physics should remain exactly the same. But here's the twist. Experiments have shown that certain symmetries are slightly violated in our universe. A mirror universe could be the cosmic balancing act. It might be a place where antimatter dominates, where left is right, and where time flows backward a perfect hidden twin that restores the universe's fundamental balance. So why should we care about a universe we can't see? For one, it could finally solve the mystery of dark matter. This invisible substance makes up about 85% of the matter in the cosmos. It's gravity holding galaxies together and shaping their evolution. For all our searching, dark matter remains completely invisible to our telescopes, interacting with us only through gravity. Now, think about mirror matter. If it existed in a parallel universe, it would behave in precisely this way coexisting with our reality. It's unseen and unfelt, except for the powerful gravitational pull it exerts on the stars and galaxies we can see. The invisible web holding the cosmos together might just be the gravitational shadow of another universe. Beyond dark matter, the mirror universe concept could explain a series of subtle, nagging anomalies in particle physics. For years, scientists have observed tiny, unexpected deviations in the behavior of neutrinos. They've found minute discrepancies in the properties of antimatter and recorded unexplained energy fluctuations in our most powerful particle accelerators. On their own, these are just small puzzles. But taken together, they might be whispers from a hidden sector of particles, a shadow world that interacts with our own so weakly that we can barely detect its influence. These aren't errors in our experiments. They could be the first real evidence of a reality far grander than we imagined. The idea of a mirror universe also forces us to rethink our most basic intuitions about life and existence. If time and physical laws are inverted, could biological processes exist in reverse? Could a mirrored tree pull carbon dioxide out of the soil and release oxygen through its roots? Could life, if it exists there, follow an inverted thermodynamic path, growing more ordered over time in defiance of our understanding of entropy? These questions blur the line between science and philosophy, pushing the absolute limits of our imagination and challenging everything we think we know about the universe and our place in it. Physicists aren't just dreaming this up. They're building concrete theoretical frameworks to describe it. Some propose mirror symmetry models, where every particle we know has a hidden twin that interacts through its own set of mirror forces. Others, working with string theory, explore brain world scenarios. In this picture, our universe is a three-dimensional membrane, or brain, floating in a higher dimensional space. A mirror universe could exist on a parallel brain, right next to ours, but completely invisible, except for gravity, which can leak across the dimensions. Each model presents its own unique predictions and paradoxes, but they all point to the same incredible conclusion. The reality our senses perceive might just be one side of a much larger, stranger, cosmic coin. And this all leads to the ultimate paradox. If a mirror universe is designed to be hidden, how could we ever prove it's there? This is where scientific creativity truly shines. Researchers are designing incredible experiments to catch the faintest hints of a parallel world. Searching for rare particle oscillations, where a particle from our universe might momentarily flicker into its mirror state and back again. They're mapping the cosmos with unprecedented precision, looking for gravitational anomalies that can't be explained by normal matter. They're even looking for mirror photons that might leak into our world. Every experiment that finds nothing helps us narrow down the possibilities, and every tiny, unexplained anomaly fuels new hope that we are on the verge of a discovery that could redefine everything. Ultimately, contemplating a shadow universe makes us confront the very limits of our own perception. What does it mean for something to be real if it cannot be seen, touched, or directly measured? Is existence only what our instruments can detect, or can something be real if it only influences our world from afar? These are the deep, challenging mysteries that drive modern physics. They are questions that start with hard data and complex equations, but lead us to the edge of philosophy. All part of the grand human quest to understand matter, energy, and the fundamental symmetries that govern our existence. As we gaze out at the cosmos, we are not just looking at a vast emptiness, but perhaps at the faint reflection of another reality, waiting to be discovered. Have you ever looked up at the night sky and wondered if what we see is all there is? What if our universe, with its billions of galaxies and countless stars, is only half of the story? The idea of a shadow universe is not just science fiction. It's a concept that speaks to humanity's deep-seated fascination with reflection, duality, and the hidden worlds that might exist just beyond our perception. Across cultures and centuries, we've contemplated mirrors of reality, parallel worlds, its unseen dimensions, and the possibility that existence is far more layered than what our senses can detect. Think about it. From the yin and yang of Eastern philosophy, representing the interconnectedness of opposing forces, to Plato's famous allegory of the cave, which suggests our reality is but a shadow of a truer form, the concept of a hidden, mirrored world has captivated human thought for millennia. Now, modern physics is echoing these ancient ideas, but with a crucial difference. This time it's grounded in mathematics, observation, and experiment. The mirror universe is no longer a myth. It's a legitimate scientific inquiry into whether every particle, every star, and every galaxy we know has a hidden counterpart, a silent twin, just beyond our reach. This isn't just some abstract theory for scientists in labs. The existence of a shadow universe could have profound and practical implications for technology, for our understanding of the cosmos, and even for the nature of life itself. Take dark matter, for instance. For decades, astronomers have been puzzled by this mysterious, invisible substance that makes up about 85% of the matter in the universe. We know it's there because we can see its gravitational pull on stars and galaxies, but we can't see it directly. What if mere matter, the hypothetical stuff that makes up the shadow universe, is the answer? If mirror matter constitutes even a fraction of this dark matter, it would mean it's directly influencing the formation of galaxies, the stability of planetary systems, and the very structure of the universe that allowed life to emerge. Understanding it isn't just an academic exercise, it's essential to understanding our own cosmic environment. Beyond the grand scale of astronomy, the concept of a mirror universe fundamentally challenges our perception of reality. If an invisible world exists alongside ours, subtly influencing it through gravity, what does that mean for concepts we hold dear, like causality or even free will? It forces us to confront the limits of human knowledge. The search for the mirror universe is a powerful reminder that our senses reveal only a tiny fraction of what truly exists. Not so long ago, we believed the Earth was the center of everything. Today, we might be on the verge of discovering that our entire universe is just one part of a much larger, more complex cosmic tapestry, with mirror matter quietly shaping everything we see and experience. This quest for hidden realms is also a massive driver of innovation and education. The challenge of detecting something that is by its nature invisible pushes scientists to develop incredibly sensitive new instruments, next-generation particle detectors buried deep underground, massive neutrino observatories, and sophisticated gravitational wave sensors that can detect the faintest ripples in space-time. This pursuit sparks incredible collaboration, bringing together brilliant minds from cosmology, particle physics, and quantum theory, all working towards a common goal. For all of us, this is a story not just about distant, exotic particles, but about the power of human curiosity, our relentless ingenuity, and our unyielding drive to uncover the invisible forces that shape our world. Even in our everyday lives, the idea of reflection and symmetry resonates deeply. It's a fundamental principle in art, a recurring theme in literature, and a central concept in philosophy. The mirror universe serves as a powerful metaphor for hidden complexity, reminding us that appearances can often be deceiving. It suggests that reality may be far richer and more intricate than we perceive. The pursuit of this knowledge encourages us to look beyond the obvious, to question our assumptions, and to embrace the thrilling possibility that the universe still holds incredible secrets just waiting for us to discover them. In essence, the search for a shadow universe is far more than just a technical or theoretical challenge. It's a profoundly human endeavor. It reflects our innate desire to understand our place in the cosmos, to reconcile what we can see with what we cannot, and to explore the mind-bending possibility that the universe itself holds up a mirror, reflecting our own existence in forms we have yet to even imagine. So, how did we get here? How did this incredible idea journey from the realm of mathematical speculation to the cutting edge of modern physics? Have you ever wondered if there's a mirror image of our universe out there? A hidden reality, reflecting everything we know? This isn't just science fiction. The quest for a mirror universe is a real scientific journey, and it began almost a century ago. It all started with a deep dive into the fundamental rules of nature. With the discovery of antimatter, the first clue that our universe might have a built-in reflection, back in 1928, the brilliant physicist Paul Dirac was working on equations that described electrons. He was combining quantum mechanics with Einstein's theory of special relativity. To his astonishment, his own math predicted something extraordinary: particles that were identical to electrons, but with the exact opposite charge. He called them positrons. At first, this antimatter was just a wild idea on a blackboard. But then, in 1932, it became real. A scientist named Carl Anderson was studying cosmic rays and actually detected positrons. Suddenly, this theoretical concept was a confirmed reality. This was the very first glimpse of a hidden symmetry in nature, a kind of mirror at the tiniest subatomic scale. For a couple of decades, physicists thought the laws of nature were perfectly symmetrical, like a flawless mirror. But in 1956, two physicists, Sung-Dao Lee and Chunning Yang, dared to question this. They proposed that maybe, just maybe, some physical laws weren't the same in a mirror image world. It was a radical idea, but experiments soon proved them right. They discovered that certain weak interactions, the forces responsible for radioactive decay, actually violate this mirror symmetry or parity. This discovery was so groundbreaking, it won them a Nobel Prize. It revealed that nature isn't perfectly mirrored after all. But this shocking twist also opened a fascinating new door. If our world isn't perfectly symmetrical, could there be a hidden mirror world where that symmetry is restored? A place with its own set of mirror particles to balance the cosmic scales? Fast forward to today, and the tools we use to explore these questions are mind-boggling. Think of places like CERN's Large Hadron Collider. Here scientists smash protons together at nearly the speed of light. These collisions create spectacular showers of particles and antiparticles like microscopic fireworks. Gigantic detectors packed with super-sensitive cameras and sensors record every single flash of energy. Researchers aren't just looking for particles they already know about. They're hunting for anomalies, for anything unexpected that could point to the existence of mirror matter's strange oscillations, or weakly interacting twin particles that could be passing through our world like ghosts. Every collision is a chance to peek behind the curtain of our reality. Now let's talk about some of the most mysterious particles we know: neutrinos. These things are like cosmic ghosts. Trillions of them are passing through your body right now, but they barely interact with anything. To study them, scientists have built massive observatories deep underground, like Super Kamiokande in Japan or IceCube at the South Pole. These experiments have revealed that neutrinos can do something truly strange. They can change or oscillate between different types or flavors. They can flip from an electron neutrino to a muon or tau neutrino as they travel. This bizarre behavior has led scientists to wonder, could they also be oscillating into something else entirely? A hypothetical mirror neutrino that exists in a parallel sector? Each time we detect a neutrino, each time we measure its oscillation, we're gathering clues that might form a bridge between our universe and a hidden mirror world. So far, we haven't found definitive proof, but these experiments are constantly pushing the limits of what we can see and measure. While some scientists look for new particles, others are taking a closer look at the ones we've already found. At CERN's antiproton decelerator, for example, researchers have figured out how to trap antiprotons and positrons. Antiprotons study them with incredible precision. They're essentially putting matter and antimatter under a microscope, comparing their properties down to the finest detail. The big question is, are they perfect mirror images? Well, if they find even the tiniest difference, it could solve one of the biggest mysteries in cosmology. Why is our universe made almost entirely of matter, with hardly any antimatter left? A slight imbalance could be the key, and it might just hint at the existence of a mirror counterpart that balances the cosmic books. With all this intriguing theory and indirect evidence, a new frontier of physics is opening up. Experiments designed specifically to find mirror matter. These aren't like the giant colliders, they're more subtle. Scientists are designing detectors that can catch the faintest whispers from a mirror world. For example, If mirror matter has mass, it should have gravity. So, a proposed experiment might try to detect the tiny gravitational pull of mirror particles on ordinary matter. Others might look for rare, weak electromagnetic interactions. These experiments are still in their early stages, but they represent a huge shift in thinking. Instead of just observing the universe we can see, we're now building instruments to actively search for a universe we can't see. This entire journey, from Dirac's equations to today's massive experiments, is a testament to human curiosity. It's a story that has unfolded over generations, with each group of physicists building on the work of those who came before them. From the theoretical predictions of Dirac, Lee, and Yang to the global effort involving thousands of scientists at particle colliders and neutrino observatories, we've been asking audacious questions about reality, symmetry, and existence itself. What started as a weird mathematical quirk has become a worldwide quest, pushing the very limits of our technology and our understanding, and this incredible journey is far from over. With every particle collision, every neutrino detected, and even every experiment that finds nothing, we refine our map of the universe. The mirror universe remains a tantalizing, elusive possibility, but the search itself is what truly matters. It illuminates a profound truth. The universe is infinitely more complex, more mysterious, and more wonderful than we can possibly imagine. This relentless quest for hidden symmetries, for shadow matter, and mirrored realities, is a beautiful expression of our fundamental desire to understand our place in the cosmos and to know what lies beyond the world we can see. As we gaze up at the night sky, we see a universe of breathtaking scale and complexity. But what if everything we observe, every star, every galaxy, every nebula, is only half of the story? What if there exists a hidden, parallel reality, a mere universe intertwined with our own, yet completely invisible to our eyes and instruments? This isn't just a fantasy from science fiction. It's a profound, tantalizing idea emerging from the very frontiers of theoretical physics, inviting us to question the nature of existence itself. Imagine a universe that mirrors ours in almost every way. For every particle of matter you see, there's a corresponding mirror particle. For every star that shines in our sky, a mirror star burns in that hidden realm. This shadow cosmos wouldn't just be a distant, separate reality. It could be all around us, coexisting in the same space, but interacting with our world only through the subtle, persistent pull of gravity. The implications of this are staggering, touching on the deepest mysteries of cosmology, from the nature of time to the ultimate fate of the universe. One of the most persistent puzzles in modern astronomy is dark matter. We know it's there. See its gravitational effects holding galaxies together and shaping the large-scale structure of the cosmos. It makes up a staggering 27% of the universe's mass energy budget, yet we have no idea what it is. The mirror universe hypothesis offers a compelling, almost elegant solution. What if dark matter isn't some exotic, undiscovered particle from our own world, but is simply the ordinary matter of a shadow universe? The stars, galaxies, and planets of this hidden realm would exert a gravitational pull on our own, perfectly explaining the effects we attribute to dark matter. Suddenly, this mysterious substance is no longer a strange anomaly, but the predictable signature of a parallel reality, its influence already written across the heavens. If this idea is correct, then the cosmos is far more populated than we ever imagined. Invisible galaxies, teeming with mirror stars and mirror planets, could be floating right alongside our own Milky Way. These shadow structures would be evolving according to the same physical laws as ours, forming spiral arms, birthing new stars from collapsing clouds of mirror gas, and perhaps even hosting mirror life. While we could never see them with a telescope, we might detect their gravitational presence. A star in our galaxy might suddenly shift its course, nudged by the gravity of an unseen mirror star passing nearby. Entire clusters of galaxies might move in unexpected ways, shepherded by the immense gravitational field of a hidden mirror supercluster. Discovering such an effect would be revolutionary, forcing us to redraw our maps of the cosmos and accept that what we see is merely one layer of a much deeper reality. The connections might not be limited to just gravity. At the subatomic level, the two universes could talk to each other in subtle ways. Some theories propose that certain particles, like the ghostly neutrinos that stream through us by the trillion every second, could have mirror counterparts. Under the right conditions, a neutrino from our universe could oscillate, or transform into a mirror neutrino, effectively vanishing from our reality and appearing in the other. If we could detect this vanishing act in our massive underground particle detectors, it would be the first direct evidence of a hidden world. This would not only confirm the existence of a mirror universe, but would also shatter our current understanding of particle physics, the standard model, and open the door to new fundamental forces and a more complete picture of nature's symmetries. Things get even more mind-bending when we consider the nature of time. One of the most audacious versions of this theory suggests the mirror universe could be running backward in time relative to our own. From our perspective, their Big Bang is our ultimate future, and our Big Bang is their distant future. In this looking-glass reality, entropy, the universal tendency toward disorder, would decrease. Broken eggs would reassemble, stars would gather gas back into themselves, and time's arrow would fly in the opposite direction. While seemingly paradoxical, this idea offers a potential explanation for the arrow of time and why our universe began in such a highly ordered, low entropy state. Could our seemingly irreversible processes, like the aging of a star or the expansion of the universe, have a hidden twin, proceeding in reverse, perfectly balancing the cosmic ledger? Of course, these are extraordinary claims, and they require extraordinary evidence. But scientists aren't just sitting around and speculating. They are actively hunting for this shadow world. Across the globe, experiments are being designed with unprecedented sensitivity. Some look for the minute gravitational anomalies that could betray the presence of mirror matter. Others, deep underground, are trying to catch the faint signal of a particle interaction that bridges the two worlds. Future particle accelerators and next-generation space telescopes will scan the heavens and probe the quantum realm for any sign, any whisper that we are not alone. Each new experiment, whether it finds something or not, pushes the boundaries of our knowledge and refines our search for this hidden reality. Beyond the labs and observatories, the concept of a mirror universe forces us to confront deep philosophical questions. If a whole other reality coexists with ours, what does that say about our own significance? Our perception of being at the center of a single, observable universe might be an illusion, a provincial view born from our limited senses. We might be just one side of a cosmic coin, inseparable from our unseen counterpart. This idea encourages a profound sense of humility and wonder. It invites us to embrace uncertainty and to recognize that the universe may hold layers of reality far beyond our current comprehension. The truth isn't just out there among the stars we see, but perhaps also in the spaces between them, in a dimension we are only just learning how to perceive. Ultimately, the quest for a mirror universe is a powerful expression of human curiosity. It's a journey that pushes us to the very edge of what we think is possible. Whether this shadow realm is ever found, the search itself is transformative. It challenges our assumptions, inspires new technology, and deepens our appreciation for the intricate, mysterious, and beautiful cosmos we inhabit. It reminds us that what we know is just a fraction of what there is to be known, a single shoreline on a vast, undiscovered ocean of reality. The shadow universe remains one of the most tantalizing frontiers in science, a blend of rigorous theory, bold speculation, and the promise of the next great adventure in our quest for understanding. We stand on the cusp of a new era of discovery. One day we may finally build the bridge to this hidden realm, peer into its mirror reality, and answer the question that has echoed through the halls of science and philosophy for decades: are we alone in the cosmos, or are we simply one half of a grand cosmic reflection?